Hi, I am Jefferson, and I am going to talk about the use of dynamic programming and image partition to reduce the runtime of alpha expansion algorithm. The developer algorithm has applied in the task of multi-level segmentation. The presentation has the following script phase. I will present the context next. I will show you the proposal that has developed with the scope of the work, and finally, I will show the result obtained in the experiment and the conclusions. This problem consists of dividing an image into a set region where each trace image is associated with a label that, in the case of its work exploring a segmentation model based on a graph representation. To represent an image as a graph, you can represent which pixel has a vertex in the graph. Each terminal node represents the label, which edge is compressed of two sets, terminal links and label links. The segmentation of the graph is performed using clusters in the graph, as shown in the figure. To find the best cluster in the graph, it is necessary to minimize an energy function. This function has two tables. The first represents the cluster of an pixel belonging to a label, while the second represents the cluster of the neighborhood relationships among pixels. Find the solution to the problem with the number of labels reaching data tree is an IP-head problem. Therefore, to resolve this problem, approximate algorithm are used, and the most common of them is the alpha expansion. Boykov, Vector, and Zeib proposed the alpha expansion algorithm in 2001. This algorithm started with an arbitrary label assigned to each pixel in the image, and that it's resolved binary graph programming to the guess the cluster. Therefore, alpha expansion algorithm strongly depending on the initial condition with was for improving the algorithm for changing its initialization. The goal for the work is to investigate the use of dynamic programming and image partition in the initialization of the alpha expansion. Your method has called the imperative dynamic programming expansion, IDP expansion for short. You propose an approximate algorithm by exporting dynamic programming and partitioning image. The goal is to define the granularity to label assignment in with each iteration of the algorithm. This is the dynamic programming proposal in York. IDP expansion uses only the data function to get an initial definition of the label and to analyze the alpha expansion. Once the image partition is generated, the minimized energy is computed by means of a dynamic programming algorithm that we call DP top-and-down. DP top-and-down works by assigning a label to each image partition and checking the new energy function value of that solution. Ultimately, this solution reduces the recalculation of the energy function. To evaluate the expansion performance, we use the Berkeley segmentation dataset. in an interactive segmentation task. Over the dataset, the runtime and segmentation platforms provided by the dice scoring metric and IDP expansion were compared with the following methods and random initialize of expansion, the PSPD and KBPO. We evaluate different strategies of image partition. Tests include the three main strategies of image partition: superfixing, over-segmentation, and gridding, where we show an ablation study of the overall runtime expected by IDP expanse while using the different methods for image partition, include tests for different hyperparameters well available. The results reveal that the grid-like partition with perfect partition is the best option. According to results, IDP expansion activates the same segmentation quality as original of expansion and SPD and is only 0.02 lower than KBPO. Considering computational time, our method is fast one. Conclusions. IDP expansion activation comparably resulted with the original alpha-expansion algorithm, while expanding uptime of convergence. The remaining time reduction has been obtained by exploring the subproblem reduction in the search space, as well as by doing image partition. Limitation and future works. Differently from alpha expansion, IDP expansion can be only applied in 2D imaging. A possible future work can be to investigate the adequate initializer of alpha expansion in other contexts, so as 3D image segmentation. The developer the auto initialization strategy can explore GPU, for example. Thank you very much for the attention.